Hey guys, so in today's video I'm going to be showing you how to make unanchored parts move along a path, and this can be used for many things, for instance cars, planes, boats and ski lifts. So let's jump straight into the video. So let's get started by creating a base plate project, and within workspace I want to create a folder, and I'm going to name this folder Paths, and inside of the path folder I'm going to create another folder, and I'm going to call this folder Test, and inside of this folder I'm going to create a part, and I'm going to name this part 01, and I'm going to anchor this part, and then I'm going to set the part to a ball shape, and I'm going to give the part a red color, and now I'm going to position this part to indicate to the script where we want the path to start. So I want the path to start here, and then I'm going to duplicate this part and move it here, and I'm going to rename it to 2, and now I'm going to duplicate this part once again, and I'm going to name this part 3, and I'm going to duplicate this part, and I'm going to move it here, and I'm going to name this part 4. I'm now going to create a model that's going to move along the path from point to point. So to do this, I'm going to create a model, and I'm going to add a part to the model, and I want to make sure that the part is not anchored. I'm going to add a decal to the part so that we know what way the part is facing, and I'm going to set the decal to be on the top face, and I'm going to change the color of the part to be green, and I think I'm going to adjust the size slightly to be something like this. And then I'm going to create a folder inside of server storage, and I'm going to name this models, and I'm also going to rename this model to be called Test, and then I'm going to move this model into the model folder. Now let's create our script. So inside of server script service, I'm going to create a script, and I'm going to call this script Paths, and I'm going to delete this print line. And the first thing I want to do is loop through every child of the Paths folder. So let's say for I folder in iPairs workspace paths get children do, and then for every folder inside of the paths folder I want to loop through every part and store their position. So to do this I'm going to say local positions equals, and I'm going to create an empty table, and then I'm going to loop through every child of the folder. So for I part in iPairs folder get children do. Now I'm going to add the parts position to the positions table. So to do this I'm going to say positions, and I'm going to use the part's name as the key so that it's in order. So part dot name, but we want to convert this name to a number, so we're going to use the toNumber function, like so, and I'm going to say equals part dot position. Then we're going to destroy the part because we no longer need the part, so I'm going to say part destroy. But because for testing purposes I still want to see the part temporarily, I'm going to comment out this destroy and say I'm going to set the parts can collide value to false. So part dot can collide equals false. Now we need to create a part that the model is going to use to move towards. So to create this part, I'm going to say local target equals instance new part, and I'm going to anchor this part, so target dot anchored equals true, and I'm going to set can collide to false, so target can collide equals false, and also going to set can touch to false, can touch equals false, and I'm also going to set the target's position, so target dot position equals, and we want to use the first position in the positions table. So I'm going to say positions, and I'm going to pass in the value 1 to start at the first position. And I'm also going to set the size of the target, so target dot size equals vector3.new, and I'm going to set a size of 444. And finally, I'm going to set the target's parent, and I'm going to set it into the folder where we got the parts from. Now we need to constantly update the position of the target part, and to do this we're going to need an endless loop so that we can constantly update the target part for an infinite amount of time. So to do this, I'm going to say while true do. We now have a problem. As the computer reads each command and comes down the code, it will enter this loop and never be able to exit the loop, because this loop goes on forever, and it will prevent the code from underneath and this for loop to continue. So what we need to do is spawn a function which is kind of like branching out of a trunk of a tree, a new function that will run independently from the main trunk of this code. So to do this, what I'm going to do is say spawn, and I'm going to put a new function inside of this spawn, so function like so, and I'm going to move this endless loop to be inside of this new spawned function. Now inside of this new spawned function, I'm going to store the position the target is currently at, and we can see that the target is currently at position 1. So I'm going to say local I equals 1, and inside of the loop I'm going to increment this I value so that the target can move to the next position in the positions table. So to do this, I'm going to say I plus equals 1. And once the I value gets to the last position inside of the positions table, I want to loop it back down to position 1. So I'm going to say if I more than positions, then I equals 1. End. Now I'm going to update the target's position, so I'm going to copy this here, and instead of setting the position to 1, I'm going to use the I value that we are looping to set the position like so. And now I want to wait a small amount of time so that the position does not constantly update very quickly. So I'm going to say wait, and I'm going to wait for 2 seconds. Now let's run the game. Now you can see this white target part is constantly every 2 seconds moving from point to point. And we can also see the part inside of the test folder right here. Now let's clone our model so that we can make it follow the target part. So I'm going to do this before we start the endless loop. And I'm going to say local model equals game.serverStorage.models, and I'm going to use the name of the folder, which is test, and we can see the model is also called test. So I'm going to say folder.name, and we're going to clone this model. And then I want to set the model's cframe to match the target part. So I'm going to say model set primary part cframe, and I'm going to use the targets part cframe, so target cframe. And finally I'm going to put the model into the folder, so I'm going to say model.parent equals folder. Now if we run the game, you'll notice that we get an error saying set primary part cframe failed because no primary part has been set. So what we need to make sure we need to do is come into our model, and here we have a primary part setting, and we want to make sure we set it to a part inside of the model. So I'm going to set it to this part here, and now we should no longer get an error. In order to make our model move towards the target part, we're going to use the align position constraint. So for the align position constraint to work, we require 2 attachments. So I'm going to create an attachment here, and I'm going to parent this attachment to the target part, and I'm going to create another attachment. I'm going to call this one attachment 1, and I'm going to parent this one to the model's primary part. Now let's create the align position constraint. So to do this, I'm going to say local align position equals instance new align position, and I'm going to set the attachments of the align position. So I'm going to say align position attachment 0 equals attachment 0, and align position attachment 1 equals attachment 1. And then I'm going to set some values of the align position. So we have the max false value, and I'm going to set this to 10,000, and we have the max velocity, and I'm going to set this to infinite, so we can say math.huge, and I'm also going to set the responsiveness, and I'm going to set this to 10, and then I'm going to set the parent to the folder, Now let's run the game and see what happens. So we can see the target part is moving, but the model is not following the target part. And the reason for this is the attachments need to be assigned in a certain order. Attachment 0 needs to be the one that moves, where attachment 1 is the one that is going to follow. And we can see that we're attaching the attachment 1 to the model. So in order to fix this, I'm going to set this as attachment 1 that goes into the target, and set this attachment to attachment 0 that goes into the model. And if we run the game again now, we can see that now that the attachments are set correctly, the model follows the target part. By changing the align position properties and the wait time, we can drastically change the way the model follows the target. For instance, if I change wait from 2 to 0.5 and change this from 10,000 down to 5,000, and if we run the game, now we can see that the part is struggling to keep up with the target part and is moving in such a way like this. So values like this may be great for things like planes, but for ski lifts, we want the part to follow the path very precisely. So to do this, what I'm going to do is set max force to infinite, and I'm going to set max velocity to 20, and I'm going to set the responsiveness to 200. Currently, we are blindly waiting half a second before we update the position of the target part. But if one of the points is far away, it may take longer to move from this point to this point than it does to move from this point to this point. Now to fix this, we have a few options. One option would be to have a touch event on the model's primary part, and when we detect the primary part touches the target part, we can update the target part's position. But another more optimal way of doing it is, if we know the maximum velocity, we can use this velocity to calculate how long we must wait to move from one point to the next point. So to calculate how long it's going to take to move from one point to the next, what I'm going to do is, I no longer want to instantly increment I, and I want to store the next value into a new variable called next I equals I plus 1. And then I'm going to check next I to make sure it hasn't gone past the final position. So I can copy this and replace I with next I. Now I want to store the magnitude between the current position and the next position. So to do this, I'm going to say local magnitude equals, and I'm going to say position with the next I as the key, negative positions with the previous position, and I'm going to get the magnitude of this. So dot magnitude. And now that we've calculated the magnitude, we can now set I to equal the next I, like so. And now we can calculate how long it's going to take. So to calculate how long it's going to take, we're going to do magnitude divided by the velocity, which is 20. Instead of playing the game, if we run the game, we can see that the target slightly moves early, But if we keep watching, we'll see that now the target is moving correctly. So the reason this is happening is because we're instantly trying to move the target part and the server has not still had a chance to settle in. So to allow the server to finish loading, I'm going to simply add a wait at the very top of the spawn of this function. And if we run the game once again, now we can see that it's waiting the correct amount of time on the first two moves. It's very important that this 20 value and this 20 value always stays the same, because if we change this to 30, now we're no longer calculating the wait time correctly. So to prevent us from making mistakes in the future, what I'm going to do is I'm going to make a new variable at the very top, and I'm going to say speed equals 20, and I'm going to replace this with the speed variable, and I'm also going to replace this with the speed variable. That way, no matter what, these two will always have the same value. Now we have the part moving to the points, but the part is always facing the same direction and not facing the point. So in order to rotate the part, we're going to be using the align orientation constraint. So let's create our align orientation constraint. First, I'm going to create a variable called align orientation. And then I'm going to use the same attachments for the align orientation. Like so. And then I'm going to set the max torque. And then I'm going to set the max angular velocity. And I'm going to set that to 5. And then I'm going to set the responsiveness. And I'm going to set that to 10. And I'm also going to set the parent to the folder. Now, in order for the align orientation constraint to work, we must rotate the target part to face the correct direction. So if the model is over here, the model needs to face towards this direction. So when we place the target over here, the target must also face that direction. And once the model gets here, now the target will need to face this direction. Now we could calculate the orientation every time we update the target's position, but it would be more efficient to calculate the orientation once at the very start and save it inside of a table and then update the orientation in the loop without having to calculate the new orientation. In order to calculate the cframes of where the target needs to go, what I'm going to do is create a new table, and then I'm going to loop through every position . And unlike here where we get the next index, I'm going to get the previous index. So I'm going to say local previous I equals I negative 1. So we say negative instead of positive 1. And then I'm going to check to see if it's 1 and we deduct 1, it'll be 0, which we don't have a 0 part. So we need to loop to the last part. So to do this, I'm going to say if previous I equals 0, then previous I equals the last position of the positions table. Now we're going to calculate the difference between the previous index and the current index, and we're going to store that in a vector free. So to do this, we're going to say local offset equals position I negative position, and we can use the previous index. And now we're going to create a cframe using this offset value. So I'm going to say cframes I equals cframe dot look at, and we're going to use the position, and we're going to use the position plus the offset, so we create a cframe that is looking towards the offset. Now, instead of setting the target's position, we're going to set the target cframe. So I'm going to change this to cframe, and then I'm going to use the cframes table instead of the positions table. And now if we run the game, now we can see that the part is facing the correct direction. We also want to make sure that the target part is rotated correctly when we first add it to the game. And unfortunately, all the cframes that we've created will not work because they're not positioned correctly. So to create the correct cframe, I'm going to say start cframe equals, and it's going to be positioned at the first position, and it's going to look towards the second position. Now I'm going to replace the position with cframe, and it's going to equal the start cframe. And while this target.cframe will work correctly, it feels more correct to me to have this set to start cframe. Now, because I'm going to be creating ski lifts, I'm going to want to put cables going from point to point to point. But if your system does not require cables, you can skip this part of the tutorial. If we look at a part with a shape set to cylinder, we can see that the cylinder goes along the x-axis. So if we want to lengthen the cylinder, we must increase the x value. And we'll also notice that the arrow is pointing this way, so if we wanted the cylinder to go along the forward direction, we need to orientate it by 90 degrees, like so, and now the cylinder is facing the correct way. Now, when creating the cylinder, we need to calculate the position, and we have already calculated the cframe and offset here, so it would be best to create our cylinder here so we can use these two values. So to create the cylinder, I'm going to first create a variable called part and create a new part, and then I'm going to anchor the part and set can collide to false and can touch to false. And then I'm going to set the cframe, and we're going to use the previously calculated cframe, but we want to rotate the cframe by 90 degrees on the y-axis. So to do this, I'm going to say And the from orientation requires radii, not degrees. So we want to convert 90 degrees into radii. We can do this by saying math.rad 90. Another way to calculate 90 degrees in radii would be to do math.pi divided by 2. Now, if we want this cylinder to be in the middle of the 2 points, we're going to need to move it by 50% of the offset. So to do this, I'm going to say part.position negative equals offset times 0.5. Now I'm going to set the size of the part, so part.size equals vector3.new, and along the x-axis we're going to use the offset magnitude, so offset.magnitude, and for the y and z I'm going to use a size of 0.5. And then I'm going to set the shape, so part.shape equals enum part type dot cylinder, and I'm going to set the part's color, so part.color equals color3 dot new, and I'm going to have a color of 0.1, 0.1, 0.1, and then I'm going to set the top and bottom surface, so dot top surface equals enum dot surface type dot smooth, and I'm going to do the same for the bottom surface. Bottom surface is smooth, and finally set the part's parent to folder, which is this folder here. Now if we test the game, now we can see that we have these black long cylinders going from point to point. Now I'm going to destroy these parts as I no longer need to see them. So I'm going to uncomment this destroy and remove the can collide equals false. And I'm also going to hide the target. So I'm going to set the size of the target to 0, 0, 0. And I'm also going to set the target's transparency to 1. Now, because I'm going to be creating ski lifts, I want there to be multiple models evenly spaced out along the path. But if you only want a single model, you can skip the next part of the tutorial. So to create multiple models, I'm going to create a loop. And for now, I'm just going to create 3. And I'm going to move this code into the loop. Now I'm going to create a table. And I'm going to call this table targets. And I'm going to store these targets into this table. So at the bottom here, I'm going to say table.insert, and I'm going to pass the targets table, and we're going to insert the target. Now you can see that we have an error here because it's no longer able to find the target variable. So what we're going to need to do is loop through every target inside of the targets table and update their C-frame individually. So to do this, I'm going to say for I target in I pairs targets do, and I'm going to move this line into the loop. Now I want the targets to move slightly at different times, so they have a offset. So I'm going to have a wait, and for now I'm just going to wait for 1 second. Now we have a slight problem. Because this wait here is being carefully calculated, it's now being incorrectly calculated because it also needs to wait for these waits above. So in order to fix this, we want to spawn a new branch and have this wait work separately from this wait. So I'm going to spawn a new function, and I'm going to move this loop into the spawn. So now this branch can run separately from this branch. Another problem that we have is we're creating a new I variable here, which is conflicting with this I variable outside here, and this table needs to use this I variable as the index and not this I variable. So we can rename this to J, but we still have a problem. Even though we're using the correct I variable, if this wait finishes before these waits, then the I variable will be incremented by 1. And now the I variable will have the incorrect value because we want to use the value that I was when the function was first spawned. So to fix this, instead of using the I variable, we can actually use the next I variable, and we know because this is defined inside of the while loop, this I variable will never change. And because we no longer have a conflict between this I and this original I, we can change this back from J to I. And now if we test the game, we can see that the parts move with a 1 second delay between one another. Now, if we want our three models to be evenly spaced apart, what we're going to need to do is calculate the total distance it takes to complete a loop and divide that distance into 3. So to work out the total distance, I'm first going to create a variable and set it to 0. And inside of this loop where we're calculating the offset, I'm going to increment the distance by the offset's magnitude. Now we know the total distance, I'm going to create another variable called local wait time equals total distance divided by 3. This is going to give us the distance, but if we want to convert this into time, we also want to divide it by the speed. And now I'm going to set this wait time value as the wait time for this wait here. And if we run the game now, we can now see that the parts are evenly spaced apart from one another. Now I'm going to create a second path, so I'm going to duplicate this test folder and I'm going to move the points over to this side, like so, and I'm going to delete the fourth point, and I'm slightly going to move these points to something like this. If we test the game once again, we can see that both paths have a total of 3 models each. And we can see that the distance between these models are very short, while the distance between these models are very large. So if we want to have roughly the same distance between each model, what we're going to need to do is, so instead of hard coding the amount of models to 3, we want to calculate the amount of models that we want. So to do this, I'm going to create a new variable called local amount equals, and I'm going to do the total distance divided by 100 because I want roughly 100 studs apart from the models. But the problem is this distance may not perfectly align with 100 studs. So what we need to do is round this value. So I'm going to say math.round, like so. And now I'm going to change this 3 value to equal this amount value. So I'm going to change this 3 to amount, and I'm also going to change this 3 to amount. So if we run the game once again, so we can see that this only has 1 model now because only 1 model was able to fit within the total distance. And this one now has 5 models. Now I'm going to be showing you how to make a lift model. So I'm going to first create a model, and I'm going to name this model lift, and I'm going to create a part, and I'm going to set my move to only move 1 stud at a time, and I'm going to move this part over here so I can see it better. I'm going to change this part to a cylinder, and I'm going to set the size to 511, and then I'm going to set this part as the primary part, so like so. And then I'm going to create a seat. So let's create a seat. And I'm going to position this seat in the same position as this part. So let's copy this position. And I'm going to move the seat down slightly. I think we need to move it slightly more. And I'm going to place an attachment to the primary part and one to the seat. And I'm going to create a hinge. And I'm going to set the first attachment to the primary parts attachment and then the seats attachment. I'm also going to move the seats attachment to align with the primary parts attachment. So to do this, I'm going to copy the world position and I'm going to paste it into the seats attachments world position. I'm also going to set the lift's primary part can collide and can touch to false. And then I'm going to move this model into the models folder, and I'm going to rename this folder from test to lift. And if I run the game now, now we can see that this path uses the test model and this path uses the lift model. I'm now going to quickly add some handles to the lift model. So to do this, I'm going to duplicate this primary part and I'm going to delete the attachment from inside. I'm going to move this part down and rotate the part by 90 degrees. I'm going to change the color and I'm going to adjust the size to 0.2, Let's change it to 0.5. And I'm going to move it to the left. And I'm going to scale it down until it touches the seat. And scale it up. And then I'm going to duplicate this part and move it to the other side. I am then going to weld these parts to the seat. So I'm going to create a weld constraint and weld the part to the seat, and the same for this. And move this model back into the models folder. Now, if you've watched my previously created NPC system video, you'll know that I talk about that client-sided moving parts are better than server-sided moving parts. So if I enable our owners shown and our regions shown, and if I run the game, and if I enable network stats and wait a small amount of time for all the parts to start moving, we can see that the overall income is around 5.7 kilobytes a second. And if I move close to a moving part, we can see that I receive ownership of this part. So as a hacker, I now have the power to move this part wherever I want to. So one way to prevent hackers from moving the parts is to force the ownership to stay with the server. So I could write model.primPart set network owner and pass in the value of nil, and this will prevent other players from receiving ownership of the moving model. But the problem with this is now the server will need to calculate all the physics for all these moving parts, and also still need to send the positions to every client over the network. So a better option than doing this would be to move the parts that move over to the client side. So let's first create a local script inside of replicated first. So I'm first going to copy the speed variable from the server script to the local script, and I also want to loop through the folders on the client side as well, so I'm going to copy this loop here, but I'm going to wait for the paths folder. So I'm going to say wait for child paths. And now I'm going to loop through every part inside of these folders and try to find these target parts. So the first thing I'm going to do in order to allow the client to know which part is the target part, I'm going to set the target part's name target, and now I'm going to create a table on the client side called targets, and then I'm going to loop through every child inside of the folder. So I'm going to say for I child in I pairs folder get children do. Now I'm going to check to make sure that the child's name is equal to target. So I'm going to say if child dot name is not equal to target, then continue. So by continuing, we're skipping the rest of the lines of code and checking the next child in the folder. But if the child name is equal to target, then we're going to insert that child into this targets table. So table dot insert, I'm going to pass in the targets table and pass in the child. So now for every target that we find, we want to create a model. So to do this, I'm going to loop through every target. So I'm going to say for I target in I pairs targets do, and I'm going to come down here to the server script because we no longer want to create the models on the server side, but we want to create the models on the client side. So I'm going to cut this code here and paste it into here. Now we're no longer able to find the start cframe, which is calculated on the server side, but we can simply just use the target cframe to start the model's position. So target dot cframe. And another problem that we have is we're trying to get the model from the server storage, but the client does not have access to the server storage. So we must move these models into replicated storage, and we're going to change this from server storage to replicated storage. So if we test the game once again, we can now see that the overall kilobytes a second has dropped from 5 all the way down to 0.2, and we can see that the lifts are still working and the test part is still working correctly. And if we look from the perspective of the server, we can see that the server does not see any parts moving, and we can also see that the client, because this part is actually created for each individual client, even if this client moves this part, it won't affect any other players in the game. And if I create a local server with 2 players, if we look at the test model on both clients, we can see that they're almost perfectly in sync. But if we look at the lifts, we can see that this lift here is not swinging much, where this lift here has a great swing. So we know that anything that has a hinge is better off working on the server side, where anything that does not have a hinge is better off working on the client side. Also, another problem with the client side is seats don't work on the client side, so it would be impossible to sit on this chair unless you create your own custom seat script. So for things that don't have hinges, it's recommended to use it on the client side. For things that do have a lot of movement and randomness to them, it's better to have them on the server side. Thank you for watching the video, and if you have any questions, feel free to leave a comment down below.